the parts that are still in use today that still need to be maintained. And once you've scanned the data, like I say, once you've actually got the physical TIFF or the raw data, that's the challenging part, to make sure that you've got all of the data from the drawing.
Hello and welcome to a new episode of CAD Talk. My name is Jörg Lantzsch, and in this podcast we are talking about computer-aided design, from software to hardware and from actual technology to future developments. Quite often we talk about digitalization in the AEC industry, BIM and related things. Today most of the models are generated digital from scratch, but what happens with the old paper material? Plans might be 20, 30 or more years old? This is a question I would like to discuss with Gordon Lewis from GTX Europe today. Hello, Gordon.
Hello. How are you?
Hey, I'm fine, thanks. Good. Perhaps we start with a little history about the company you're working for. We had a discussion last week, so I know a few things, but it's quite a long story.
Yes, it is. Yes. Well, my name's Gordon from GTX Europe. GTX Europe were a subsidiary of our head office called GTX Corporation in Phoenix in Arizona. GTX Corp was founded back in 1987 by a Dr. Marvin Ling, who had the idea about working with scanned images or digitizing, transforming them into vectors. So back in 87, long before my time, the company had hardware and software. So we had a system where users could feed in a scanned image, let it run overnight, and then in the morning it would spit out this vector file, which then they could obviously use within their CAD environment. So in 1984 that GTX Corp was founded. In 87, GTX Europe was founded in the UK. So as a subsidiary, we were in charge of the UK, Europe, Middle East and Africa. And in the 90s, the company then started to produce software, predominantly for AutoCAD products. So our first version, I believe, was in release 14 of AutoCAD. Very simple application where users could load in a scanned image, do various editing commands on the product, on the image, but actually working within the same environment. And obviously since then, AutoCAD's now up to release 2027. So from release 14, must be up to probably release 30, I guess now. So yes, we've been working with Autodesk and AutoCAD products for many years now.
And you mentioned that the company also produced hardware, scanners, but that was skipped in one point in time, right?
Yes. Yeah. Well, they weren't scanners as such. It was hardware box. So obviously you had the scanner that produced the initial TIFF image or the scanned image. And then we had a bit of hardware with the GTX software in it so that it would actually convert and, edit the scan or convert the scanned image into a CAD file.
Okay, a dedicated computer.
Yes.
Something like today an NVIDIA chip would do.
Well, yeah. Probably your phones, or calculators probably got more processing power than that had back in the day. But yes, it was an introduction to it, and obviously the technology and software has moved on hugely since then. So, but yeah, it was the starting point. It was, what created the technology that we see today.
Tell us a little bit about the product today. It's, I think, two different type of products you sell.
Yeah, we've got multiple products. So our CAD application is what we call RasterCAD. So GTX RasterCAD is developed to run within various CAD applications. So back in the day when we were predominantly just Autodesk, AutoCAD, we now support various other CAD applications like BricsCAD, ZWCAD. So users aren't restricted to what they can use as their CAD application for GTX. And we're looking at more and more CAD applications as we move forward so that we are more CAD independent. We're not solely, those three CAD applications. So it opens the market, opens the customer base, and, that people still have a need to work with these images.
And these, usually your software runs as an add-on to these CAD softwares.
Yes, yeah, that's right. Yeah, so we install and add our menus, commands, functions within the same environment. So whether it's BricsCAD or AutoCAD, the user can be within the same environment that they know and that they're used to using. So that then you're not switching from one application to another and back again and forth. So yes, we install within that environment, and we support all of the versions, right up to the current versions that are available.
So what exactly is the software doing today?
What the software does, we have, I would say, probably three main functions that somebody would want to do to the drawing. So initially, obviously, you can load the file into AutoCAD, BricsCAD, you can view it, but you can't do anything with it. So if somebody wants to make a change or a quick modification to the drawing, like change some text or erase something, they don't need to redraw it from scratch. They don't need to go in and say, right, I need to redraw this whole complete drawing and just to make a simple change. So the software allows the users to clean up the drawing first. So it's like a despeckle. So you want to get rid of all of the background noise, all of the, some dirt, some tears, wherever the drawings have been stored or how they've been stored over the years. They could be in quite a bad state. So, you want to initially clean up the drawing so that you can actually manipulate it and read it. Then users might want to do a change, so that they'll have somebody that will mark up the drawing or mark it up and say, right, I need to change this part here, we need to change this bit here. And usually they just erase the part, they can add a new part, they can, draw as a scanned image. You can erase items, basically use all of the GTX tools for the raster elements in the drawing as you would it being a line, an arc, a circle, bit of text, things like that. So we have intelligent object picking methods that allow us to individually select a line, an arc, a circle, certain elements within the drawing to manipulate. And it's all done in the same raster world so that they can make the change, save it as a TIFF or as a PDF, and they don't need to physically redraw it from scratch just to make a quick, simple change.
But the second part is doing or converting the image to vectors, right?
Yes, yeah. I mean, that would be obviously the final goal. The users, like I say, if they just want to make a simple change to the drawing, they wouldn't have to necessarily convert everything. But to get it into the digital world, i.e. your CAD environment, you might want to convert it to DWG. So you're converting all of the raster geometry into lines, arcs, circles, so that you can actually physically use them as CAD elements. So what GTX does, we can select all of the geometry in the drawing and we can do either CAD conversion, which is like, say, lines, circles and arcs, or we can do like polylines and splines for like outlines and shapes and things like that. And generally that leaves the text behind. So text generally is away from the geometry. So we have a character recognition algorithm within the software which allows users to train up handwritten text that could be joined up. The whole character string could be joined up, could be 10 different handwriting styles on the drawing over the years. And we train up a character recognition file on the characters, and then it starts to remember and actually say, right, okay, this is this character, yes, and it puts it down at the right place at the right height. So once you've trained up this character recognition file, then it becomes more and more automatic on how it picks and converts the data or the text into proper editable CAD text. And then the end of it, you get rid of the TIFF and you don't need that anymore. You save it as a DWG. And then, you can use it as a normal CAD file.
When you have the application, we are doing a lot of podcasts in the AEC industries. So if you find lines or circles or arcs, this might be a staircase, a window, a wall, or when it comes to mechanical things, a machine that would be a screw, a sprocket, or something like this. Is the software able to detect objects out of the lines, out of the vectors?
We don't do sort of object or symbol recognition, because obviously you can, once you've created the vector data, you can obviously create a block out of that and then create your own library or your own block element. The software will trace the line, so it will go through the center of the line and give you the best representation that it can. But it won't go and say, okay, this is a door opening, make that a door opening, because all the software sees is a series of dots that are joined together. We can see it's a line, we can see it's a circle, but the software just traces it round until it comes from sort of break to break, if you like. So it doesn't do symbols or blocks, but it gives the users the ability to then, once they've created the vector data, they can then create their own blocks from it or insert their own blocks to where it should be. But it's really, whether it be a mechanical engineering drawing, whether it be an architectural drawing, or, a map, or, well, not so much maps, but utilities, things like that. It gives the user a base to then start with, rather than having to start and redraw a drawing from scratch, because their time is more valuable, doing proper design work than tracing over over lines, arcs, and circles.
Okay. You just mentioned a few industries your product is used in, like architecture and things. Do you have an overview, a distribution of your customers? How many are in the AEC industry, in machine building or others, utilities?
Off the top of my head, I would say that predominantly our software is using mechanical engineering, utilities, oil and gas, more engineering plans. We do a lot within the automotive industry, like Ministry of Defence companies, things like that, that still have parts that are in service that still need to be maintained. New buildings or architectural firms, things like that, they generally would use the plan as like a layout for, this is a site plan. And then they would redraw on top of that the new building that they want to produce. So, I think, as you mentioned earlier, a lot of architectural new drawings are generally done from scratch. They're new designs, they're 3D modeled, they're everything else. But ours is predominantly for parts that are still within service, still need to be maintained, like power plants when they're being refurbed, things like that. Elements that, they still need to refer back to the old drawing or the old scanned image in order to rework the part or re-engineer it or, make changes to it.
Do you have an idea what the oldest drawing is your software ever converted? An architectural plan from the Middle Ages or something?
It was, on a slate, yeah. It was actually on linen. It was a water company that was using old linen for their drawings, because obviously paper stretches over time. It was before they had sepia and film, so it was actually done on linen. So yeah, we actually had to do some linen drawings. Obviously they scanned, that was the main effort, was to try and to get the scan data the best quality that you could get in order to work from. But yeah, we've had paper drawings that have been screwed up, lost for years, that somebody suddenly found and was like, what can I do with that? It's like, wow, where did you find that? But yeah, it is amazing, the parts that are still in use today that still need to be maintained. And once you've scanned the data, like I say, once you've actually got the physical TIFF or the raw data, that's the challenging part, to make sure that you've got all of the data from the drawing, because if you can't scan it and it's missing, how do you know that it was there in the first place?
When we had our conversation last week, it immediately came to my head that, are you not running out of customers? Because everything today is built digitally from scratch. And one day or the other, all old paper drawings have been digitized.
Yes, I would say that the software's been around for 40 years now. So the technology, shall I say, has been around for 40 years. There's always new customers that we get. There's customers that get given a SCF because people don't want to give them the CAD file. So they'll give them a printed or a scanned PDF that they then need to work with. So we do get instances that way, which are newly generated. And there's still lots and lots of customers around the world that are still behind the curve, if you like. They're still, looking at digitizing. They're still looking at scanning their data. Europe, you'll be surprised that there's a lot of well-known companies in Europe, big companies that are still using the technology because they still have the old legacy data which they need to refer to. I mean, we had a company not so long ago. I'd never used it before, but they had a 24-meter long scan. So you're talking 24 meters in length that they wanted to do something with. They had to put a part on it. They had to change a line, a track or something like that. So we still get, some great opportunities where we think, I didn't realize it would be used for that. We've had people that want to trace round car doors because they want the shape of it, which they can put, believe it or not, armored plating into it for car doors. So they just want the polyline, a closed polyline of the shape, cut it out on a CNC machine. There you go. There's your armored plating. So there's lots and lots of different lots of different opportunities for the software. So, yeah.
You're not running out of customers.
Hopefully for another 40 years.
Okay. So the development of the software, the future development, we were talking about artificial intelligence, AI. It's not incorporated in your software yet. Will it become more powerful in the future, or is the software as it is today state of the art and that's it?
No, I mean, we're always taking feedback from customers and partners as to, new elements within the software, new ways to help with workflow. For instance, embedded images. People want to have an image embedded into the DWG and work on it. So, we look at those to help customers' workflow. We also look at licensing technologies, make it easier, quicker, simpler to license and activate the software. And you mentioned AI. With raster scanned images, you're not talking intelligent data, you're talking pixels. So you're talking, dots on a screen. So AI, you couldn't really sort of say, right, find that dot, follow that dot, and we do that anyway when we convert it. But I would say certainly for possibly the character recognition, how we use different libraries, different languages, different fonts, styles, things like that. AI could become more useful to say, right, okay, we got all this text in French or in German or Spanish in this drawing, convert it to that language. And instead of training up the file on the characters, because some languages have special characters within them, we can do it through AI. So it is a discussion on future developments for the software. Where do we go? Because AI is a big buzzword at the moment. And possibly that's probably the area that we would probably invest some R&D and some time to see how we can, incorporate some AI technologies in our character recognition for our text conversion.
Okay. Cool. So thanks very much for the interesting discussion. Of course, we'll put the website where you, the listeners, can have a look at it in the show notes. And thank you very much.
No, not a problem at all. Pleasure to speak to you again.
Okay. So, and to the listeners, I hope you enjoyed this episode. If not, please let me know what you like and what we could improve in the future. The easiest way to do this by email to info@cuttalk.de. If you have any suggestions about topics we should cover in the future or potential guests, I'm happy to hear from you. And of course, please click the follow, subscribe button in your podcast player so you won't miss the next episode. For today, I say goodbye, and I hope you will listen again to the CAD Talk next month.